Hi everyone on the forum. I thought I'd do a video. I'm going to try and explain it as best I can. It's quite difficult to put into words, but the video basically goes through the unfortunate scenario you might find yourself in should you attempt to upgrade the software on one of these Chinese import gimbals. Generally, these gimbals, or certainly the one I had, which was quite cheap, was supplied with hacked firmware on the processor on the processor on the actual board. And what happens is, if it works perfectly well until you attempt to upgrade it. Now, what I've done here is I've deliberately upgraded it with legitimate software to demonstrate what happens. And what happens is you brick it, door stop it, whatever you want to call it. What happens is, in the process of upgrading the software, not only do you corrupt the application code running on the processor, but you also corrupt the bootloader. Corrupting the application software or firmware on the processor is not really a big deal because you can reflash it, but corrupting the bootloader is more of a big deal, because the bootloader is just a small piece of software that runs on the processor like any other piece of software. It generally runs in one of the low pages. It does on PIC processors, and it probably does on this processor. And what the bootloader does is essentially invisible to the user most of the time, but it acts as a software communication link between the processor on the board and the software that runs on the PC, and that runs through what's called an API, or an application programming interface. So the PC can send the bootloader command saying, I want to upgrade firmware, or I want to do this, or I want to do that. The bootloader can report stuff back to the software on the PC, and there's this sort of seamless communication that goes on between the bootloader and the PC application. If the bootloader gets corrupted, then basically you're slightly up a creek without a paddle, because now you've got no way of getting new firmware back onto the processor, because the bootloader, which acted as the interface, is being corrupted. So the only option you've got, other than buying a new control board, is to reflash the bootloader. Now, you can't reflash the bootloader over the USB interface, because the bootloader itself was on the other side of the USB interface, and if it's corrupted, the communication's not there. Even if the bootloader is corrupted, when you plug the board into the USB here, you'll still see a COM port, because you're seeing this chip here. This little chip here, I hope this is in focus. This little chip here is a USB to serial interface chip, and it's hardwired. So when you plug in the USB, you'll always see that. You'll always see a COM port, no matter whether you've got any bootloader, whether you've got anything on the processor. You could take the processor off the board, and you'd still see this. So that's not the issue. The issue is that you've lost the bootloader on the processor, and you can't reprogram the bootloader over the USB because the bootloader is not there. So what you have to do is you have to reprogram the bootloader over the SPI interface, or as a serial interface, and this is just power, ground, reset, clock, and a bidirectional 2-wire serial interface. Now, to be able to program the bootloader over this interface, you need a little programming board. It all sounds complicated, but it really isn't. I picked this little programming board up. This is a USB ASP board, and it was £2 or £3. I forget. It was less than £5 delivered. It's got a header on it, because it's generally designed to plug directly into an Arduino board. This is essentially an Arduino. Where's my pencil gone? This is essentially an Arduino board. It's just been adapted specifically to be a gimbal. So with some jumper cables, and it's really easy. It's just ground to ground, power to power, reset to reset, MISO to MSIO, just pin to pin. So it's not difficult to connect. Once you've connected it, you're now in a position whereby you can reflash the bootloader on the processor using the Arduino software, or PC software I'm talking about. That PC software just allows you to set the programmer you're using. I set this up. You can say I want to use this particular processor the programmer in this case, the USB ASP board. You say you select the processor. I'll show this in a minute, and then you just say program, and it programs the bootloader. Once the bootloader's back on the processor, now you're home and dry, because once the bootloader's there and it's all working, you've now got the option. You've got two options then. You can either, the first option is the one I'm not condoning, and I'm not saying you should use hacked software, but the board did come with hacked software. You can either reprogram the board via the bootloader over the USB with the hacked software it came with, in which case you're back to square one, and you don't upgrade the software because you'll just brick it again. Or you can reprogram the board again via the bootloader with open source Gimbal software, which is perfectly legal because it's been made open source, and you can access the source code, and you can download what in Arduino land is called what is it called? I've forgotten now. Hang on a minute. Sketch. That's the word. You can upload it as a sketch and then burn it onto the processor again via the bootloader. So I'm going to go through the 3 steps basically. How to get the bootloader back on via this programming interface, and then once you've got the bootloader on, how to reprogram the hacked software, which I'm not saying you should do, because I suspect technically it's illegal. Well, it is, and then the other route, which is the route you should be taking, which is to reprogram the board with open source software. I hope that sort of made sense. It made sense in my head, but that doesn't mean it actually made sense. But you can always ask questions, because I've done all these different routes and they all work. And so yeah, all good. Anyway, so I'm going to do some screenshots and then some talk over of how to do those various steps. Anyway, thanks for watching, and I'll post the other videos. Cheers.
Okay, this is showing the Arduino PC software. So what we're doing here is we are setting the board type, the processor type, selecting there. Now we are selecting the programmer, USB ASP. It's that simple. And then there's a menu option which just says program bootloader. So hit program bootloader, and then it says at the bottom there it's burning the bootloader. Takes a couple of minutes while it's doing this. The green LED on the gimbal board flashes very, very rapidly as it's programming the bootloader. So I say it takes well, I don't know, I didn't time it, a minute, maybe 2. You get with this particular version of the USB ASP, you get a few warning messages at the end about clock rate not being able to be set, but that's only because the firmware on the USB ASP programmer is slightly out of date. It doesn't affect the fact that it can program. It's perfectly there. You get some messages here at the bottom. Don't worry, if you update the firmware, then you don't get those messages. So, but as I say, it programs a bootloader just fine. So if you see those messages, don't worry about it. Just ignore them. And that's it. Quit it, and it's done.
Okay, so we've now reprogrammed the bootloader, and I've disconnected the bootloader. Disconnected the programmer from the header, because it's no longer required. The bootloader is now on the processor, and I've now connected the gimbal control board to the PC just on its normal mini USB. Now the critical difference here, you'll notice, is we've still got power. Obviously, this board is being powered via the USB. Oh, one thing I forgot to mention: before you do any of this, I would suggest you disconnect the motors, because if for some reason the firmware does decide to turn the motors on and you've got the USB connected, only the USB, there's no power, it's only USB powered here, there's no way the USB is going to be able to supply enough juice to drive these motors. And you don't need it at the moment anyway, so just unplug them. So basically all you've got is a control board connected to the USB. Right, no motors. You notice the red power light's on, but now the green comms light is flashing periodically about 1 hertz. That wasn't happening before because there was no bootloader, and that comms light indicates that's being controlled by the bootloader, because that's all that's on the processor at the moment. There's no gimbal firmware. All there's running at the moment is the bootloader, and the bootloader is just pinging or polling the PC via the USB, and there's a green light flasher, which means the bootloader is alive and well. Okay, so now what we're going to do, again, I don't condone doing this because this is cracked software, but it was the software that was supplied with the gimbal. Also, I'll now reprogram the gimbal via the bootloader with the same software that it was supplied with. Okay, here we go.
Okay, here we are going to program the software. So we're selecting the COM port, selecting the baud rate at 57600 baud, selecting the file. This is the null version of the file, which is the cracked software I mentioned before, which was supplied with the gimbal. We've got the show result tick box check, and we've hit the program or flash firmware. There's a little progress box that tells you how it's progressing. Hashes showing you that it's flashing. Now it's flashing this firmware via the bootloader, so it's over the USB. That's it. It's done. It's that quick. It's that simple. It says it's finished. No errors. All good. Close it all down. Done. Okay, we're going to go through the another option, which is programming the gimbal with brushless gimbal controller software for camera stabilization, which is open source gimbal control software written by a selection of guys. I provide the link to the website. They've written all this software themselves, the PC GUI and also the firmware for the processor. Seems to work extremely well. I haven't done too much testing, but it looks pretty good to me. Anyway, so this is the other approach, which is to use this third-party software rather than cracked software, which is obviously not a great thing to do. Anyway, so this third-party software is programmed via the Arduino PC software, and it's just imported as an Arduino sketch and compiled and programmed in the same way as any other Arduino project. So anyway, here we go. Okay, so we open the sketch, BRUGI, and basically just hit upload, and it compiles the sketch. It will upload, once it's compiled, it will upload it to the processor, to the gimbal, which is an Arduino platform, in the same way as any other Arduino project would be uploaded. Doesn't take it very long. There. Uploading complete, and that's it. You're running a gimbal.